Now we're going to cover section 4.6 using more than one pair of congruent triangles. So you're going to see that there's going to be one pair of triangles you prove congruent and then another pair after that. It's going to be a longer proof, as you see on the example on page 147. So let's work through some of the examples they have here. Page 148, classroom exercise number 1, we got diagrams like this. We got A, B, C, D, E, F with points S and T here, and those are the congruences. So what we're trying to do here is show that AS is the same as DT. Now notice that to do that, we're going to have to pick out triangles. So notice AS is part of ABS and is part of ACS. And DT is part of DET and DFT. So we have to use one of these smaller triangles and make a congruence to show AS is equal to DT. So we'll probably use the one on the right here, because this doesn't have much information. On this triangle, what? You got one side and that's it, because this is the whole angle. Here we got two sides, so it's probably there that we're going to be needing to do something. So we probably want to show ACS is congruent to triangle DFT. So we're probably going to do that. Okay, and then we'll do more from there, one thing at a time. So first of all, of course, we want to put our given. So we've got AB congruent to DE and AC congruent to DF. That's given. And angle BAC congruent to angle EDF. Okay. Notice right away we have side, angle, side. We do them going around clockwise, not just any order we want. It's not side, side, angle. It's side, angle, side. We go around as we find them and name them. SAS. Same thing here. SAS. So we have a theorem that's applicable here to show that big triangles are congruent already. So triangle BAC is congruent to triangle EDF by side, angle, side. And that's what we wanted to do, almost. We're going to get there. So the big triangles are the same. Now, because of that, whenever triangles are congruent, all their parts are congruent. So remember, we're focusing on these, so we know that in this triangle, this angle is congruent to this one. So this big triangle here goes with this one, and the 2 and the 3 are here, and the 2 and the 3 are here. So these angles correspond, so they're congruent. So we know automatically angle C is congruent to angle F by CPCTC. Whenever you have congruent triangles, as we have, then the corresponding parts are congruent. Okay? Now, we can go to these triangles that we wanted. This one here, and this one here. So if we ignore this for now, ignore this for now, notice again we've got side, angle, side, side, angle, side. So we know triangle ACS is congruent to triangle DFT by the side angle side theorem. And then AS is congruent to DT by CPCTC. Done. Okay, that's number one. So now let's try number two, which says in this diagram PA is congruent to AK and LA is congruent to AN, and we're trying to show that AX is congruent to AY. That's what we want to conclude. With this diagram and this given information, we want to end up knowing that this is true for sure. So we've got to show a few triangles are congruent. So let's work through this. Let's write down our given first. AP congruent to AK and AL congruent to AN, and that's given. Now if we see AX, it's part of this little triangle and this little triangle, or this one and this one. So we need more information, more angles, more sides to show that some of this stuff's congruent. Okay? And this time, which triangle we pick to show, to end up with this, it's more optional. But first thing we need to do is start with the big triangles, PAL and NAK. You need to learn to look at that option, because this whole thing and this whole thing is the same. Since we have vertical angles, we know that so this angle and this angle, because these two lines make vertical angles. Okay, so we know that PAL is congruent to KAN by the vertical angle congruence theorem. Okay. So, but then we have side angle side. Going around in the big triangle in order, side, angle, side, side, angle, side. This pair of sides is congruent, these angles are congruent, and then this pair of sides is congruent. So we know the big triangles are congruent. PAL triangle congruent to KAN, kind of like with the angles. That's side angle side theorem. Now, because the triangles are congruent, corresponding parts are congruent. So we know that in this triangle, this angle corresponds to this one. See how we got the thing with 2 on it and the thing with nothing, the thing with 2 and the thing with 1. So there, that's how we can match these up. Or if we get this and rotate it around, this would end up down there. Okay, so we say angle P is congruent to angle K by CPCTC. But we can use vertical angles in here again. We know that this angle and this one are congruent because we've got this line and this line. I'll put them in pink, I guess. That's just what I have available, sorry. But this one and this one, they make opposite angles, and opposite angles are congruent. So, and I'll just call these a number. I'll call them angle 1 and angle 2. So, angle 1 congruent to angle 2. So, vertical angle, congruence theorem. And then notice that we have angle, side, angle. In this little triangle here, in this little triangle here, angle, side, angle, angle, side, angle. So by angle, side, angle, the triangles are congruent. So triangle PAX is congruent to triangle KAY by angle, side, angle theorem. And then finally, AX congruent to AY, because AX is a part of this triangle and AY is a part of this triangle. And when triangles are congruent, all their parts are congruent. So we've got AX is congruent to AY by CPCTC. Good.